Hello guys, welcome to today's tutorial. Today we'll be continuing our video on the node voltage method, but we will be doing a special case of the node voltage method known as the supernode approach. How then do we notice that, or do we realize that a circuit should involve the supernode approach? So in this diagram we are asked to use the nodal analysis or the node voltage method to calculate for the nodal voltages. So first of all, let's identify what our nodes. So you can see we have a node here, another node here, and we have our bottom node, which is the reference. So what do we do when we are using the nodal approach? We have to assign voltages to the nodes. So at this node, let's call the voltage what? V1. At this node, let's say there is a voltage V2, and we have what? Our reference voltage V3, which is 0 volts. So the next thing to do is to what? Write KCL at the non-reference node. But you realize that in this diagram we have a voltage source which is connected between two non-reference nodes. So the supernode approach comes in when you have a voltage source connected between two non-reference nodes. If that happens, it means you have to consider those two nodes as a single node, which is the super node. So it is similar to what the super mesh. You realize the super mesh occurs when we have a current source between two meshes. If that happens, it means you are going to consider those two meshes as a single mesh, then write KVL. So the same thing applies to the supernode. When we have a voltage source connected between two non-referenced nodes, it means we have to consider those two nodes as a single node, then we write KCL at that node. And in super mesh, we realize that if we have the current source between two meshes and there is a single resistor which is in series with that current source, whenever we remove that current source, we remove it together with what? The resistor. Let's do a quick revision here for the super mesh. So like this. The super mesh, we have this current source between these two meshes, so it becomes a super mesh. But when we are removing or we are enclosing this current source, we enclose it or we remove it together with what? This resistor. We don't leave the resistor there. So the same knowledge comes here. If we realize that this voltage is causing what? The supernode, we are going to remove it or we are going to enclose it together with any element connected in parallel with it. The super mesh is any element connected in series, but the supernode is any element which is connected in parallel with that voltage. It has to be removed together with this voltage. So looking at this diagram, this 2 volts is connected in parallel with what? The 10. It means we are going to enclose this whole portion. We are going to enclose this whole portion and consider it as a single node. That's the idea of what? The supernode. So if we are solving this, I would love to draw the diagram again and see what is happening. We are going to represent this portion with what? A broken lines, like how we did for the super mesh. So we have our current, we have this 2 ohms. This is where we have what? The 2 volts. And this is where we had what? The 10. So I'm representing those portions by a broken line. We have this resistor and we have our 7 amperes. So this is 2, this is 2 ohms, this is 4 ohms, this is what? 7 amperes. And we've already assigned our node voltages V1 and what? V2. Good. So what then do we do? Comparing it with the super mesh. After removing here from the diagram, we do what? We assign our current here like this, I1 and what? I2. Then we write what? KVL in this single mesh, which is the super mesh. But we note that the current flowing through this resistor is I1 and the current flowing through this resistor is what? I2. So that same idea is here. We are going to write what? Kirchhoff's current law, because we are doing nodal analysis. Nodal analysis deals with KCL. So we are going to write KCL at the supernode. Okay, this supernode, this whole portion is going to be treated as a single node. So you realize that this current 2 amperes is entering that super node. Okay, the whole portion is one node. So this current is entering. We have assigned current on the various branches. So let's say this is I1, this is what? I2, and this is 7 amperes. Alright, so we have I1, I2. We can't assign current here because it is part of what? The super node. So if you are writing KCL at the super node, you realize that 2 amperes is entering the super node, I1 is leaving, I2 is leaving, and what? 7 amperes is leaving. This node are what? Being considered as a single node. So whatever current is entering this way is entering that super node. This one is leaving, leaving, and leaving. So we are going to write KCL at what? The super node. So let's see how that one works. KCL at super node. So KCL at super node. What do we have? We have the 2 amperes entering is equal to I1 leaving, I2 leaving, and what? 7 amperes also leaving. So we can group them. So we can have what? This one coming here. We can have -5 is equal to I1 plus I2. So we are still doing nodal analysis. Alright. So after we get this, we have to do what? Express each of the currents in terms of its node voltages. So the same thing like the mesh. When we are writing KVL, you realize that current in one of the resistors, let's say resistor R1 will be I1, current in the other resistor R2 will be what? I2. So we are now going to express each current in terms of V over R. But don't forget that this I is from where? It's from the super node. But its node is what? V1. So I1 is starting from V1, moving to where? The reference over the resistor. So V1 minus the reference over what? 2. That is for I1. So I1's node is V1 and I2's node is what? V2. They are all having separate nodes. So I1, so we have -5 is equal to I1 is V1 minus the reference over the resistor 2 plus I2 is what? V2 minus the reference over the resistor what? 4. So here we can find the LCM and multiply through. The LCM is what? 4. So let's multiply through by 4. We have -20 equals 2V1 plus V2. So we can call this one what? Equation 1. Now we are supposed to solve for the node voltages. But we have a single equation with how many unknowns? 2 unknowns, V1 and V2. So we can't solve this because the number of unknowns is more than the number of what? Equations. So what then do? We have to bring in another what? Equation. So like the super mesh. After writing the KVL, we now go and write KCL at where the super mesh occurred. You realize that in super mesh we write KVL, then we write KCL at where the super mesh occurred. So in nodal analysis too, in super node, after writing our KCL, we need another what? Equation. So we are going to write KVL in the loop because we write KVL in the loop or a mesh. So we are going to write KVL in the loop where the super node occurred. Very good. So looking at this diagram, we realize the super node is occurring here. We are going to write the KVL with reference towards the ground, with respect to the ground. So the super node occurred here. So there is a loop here where the super node is part. This is where the voltage is. So we are going to write KVL in this mesh. Or loop. That is the loop where that voltage is making part of that loop. Okay, so looking at this diagram, we are going to write what? Let's say we are writing the KVL in this diagram. So we know that KVL deals with what? Adding voltages. So we have this voltage. We should get the voltage here and get what? The voltage here. So what is the voltage here if I ask? You realize the voltage here is what? V1. Because I1 is what? V1 over 2. So the voltage across this element is the V1. The voltage across this 4 is what? V2 minus the reference. So the voltage across here is what? V2. What is the polarity? The current is given to what? Move down. So it means the V1 has plus, minus. The V2 is also what? Plus, minus, because the I2 is moving down. So we are going to write KVL at where the supernode occur, where the voltage is making part. Okay, you check the loop where the voltage is making part of, then you write KVL in that loop. So you write KVL in, let's say, loop 1. So let's start from this voltage. We are moving clockwise. So we have a positive voltage, so 2. We come here, we have a negative voltage. We know how to write our KVL. Minus V2. Then we come here, we have what? A positive voltage. Plus what? V1 is equal to 0. We are moving clockwise like this. We are starting from here. We enter negative, leave positive. We enter positive, leave negative. We enter negative, leave positive. So when we group like terms, we have V1 minus what? V2 is giving us negative 2 as what? Our second equation. Now we have two equations with how many variables? 2 variables. So we can solve this simultaneously and get our V1 and our V2. So let's solve this. For the first equation, we have 2, 1, minus 20. For the second equation, you have 1, minus 1, minus 2. So when you solve, you get your V1 to be minus 22 on 3. Then you get your V2 to be minus 16 on 3 volts. So that is our node voltages V1 and V2 using what? The supernode approach. So that's how we use the supernode approach whenever we are giving a circuit. You should first of all note that there should be a voltage source between two non-referenced nodes before you can use the supernode approach. Thank you very much for watching this tutorial video.